Hello students, welcome to another e-learning session. As in the previous classes, we have discussed about matrix, various types of matrix and algebraic operations of matrix. So today we are going to discuss another matter in matrix. That is, as I already make you know that matrix is used to solve various linear equations. Okay, for that purpose we need to construct a equation and then that equation is solved using the matrix. So in the process of solving the matrix, some other factors are required to solve that matrix. Okay, so that factor or that element is known as determinant. Determinant. Okay students, see, as like matrix, determinant is also another chapter in our syllabus. Okay, so determinant is important to solve the matrix. Okay, to solve the matrix, that is a part or that is a process which we required to solve the matrix. Clear? That part is known as determinant. Okay, so by applying this technique or this factor, this element, we can move forward to one process, or we can complete the first process that we required to solve the matrix. Okay, so today we are going to discuss about what is determinant, a brief introduction, the characteristics of determinant, and some other factor relating to determinant which are helping, or we can say those are the helping tools in solving the matrix. Okay, clear students? So first of all, I want to give a brief introduction about determinant. Brief introduction about determinant. As like, determinant is a factor. Okay, determinant is a factor which is very useful and important for solving matrix. Is an important factor, determinant, or it is an important in solving matrices. To solve matrices, we need that determinant. Okay, and it is developed in the year 1750. It is in the year 1750. It is developed in the year 1750 because, as we know, everything are developed because of some requirement. Okay, so when there was a requirement for solving various equations, the determinant was developed, and it was developed and used by a famous mathematician, Gabriel Cramer. Gabriel Cramer. Gabriel Cramer. Okay, that the famous mathematician who developed the determinant to support the concept of matrix. Okay, so that is a brief introduction about determinant, because as I already told you that for each and every factor, okay, whatever we study, whatever we learn, first of all, we just need to know the origin of that particular factor and who are the person behind that origination. Okay, so that's why it also may be a interview question, short objective question asked, required to know that who is the developer, who is the originator of the particular concept. So that's why I am suggesting here that determinant is developed by Gabriel Kramer in the year 1750. Clear? Other things, a long introduction, okay, is not required. That is enough. Okay. So now, what is the meaning? What is the meaning of determinant? Okay. See students, what is determinant? The determinant is a numerical value. Is a numerical value obtained from a square. It is a numerical, determinant is a numerical value obtained from a square matrix. Okay, that is important. As students, we have discussed about different type of matrix. Though we can solve or we can find or we can apply determinant only in square matrix. Other matrices are not applied, clear, to find the determinant. Okay, so say, so determinant is a numerical, determinant is a numerical value, is a numerical value obtained from a square matrix, obtained from a square matrix of the coefficients of certain unknown variable, enclosed by bars, by the process of enclosed by bars, by the process of diagonal expansion. Okay. So determinant, what is determinant? Determinant simply is a numeric value. It is a numeric value, a number. Whenever we are going to solve or whenever we are going to find the determinant, it means we need to find a number, numeric value, okay, which is obtained from a square matrix only, from a square matrix of the coefficient of certain unknown variable. As we know, there are various coefficients or that we call the elements, okay, as we know, like A11, A12, A13, A21, A22, A23, A31, A32, A33. So that is a square matrix. Okay, square matrix students. Equal number of row, equal number of column. It may be 2 or 2, 3, 3 and 4, 4. Clear? So it is a square matrix. So coefficient of certain unknown variables. So these are the unknown variables. Okay. Those things. Okay. We can find determinant of each and every unknown variables. Okay. And those are enclosed by bar. Simple bar. Okay. In the matrix, what we do, we use to enclose by square bracket. Okay. But here in the determinant, we use only bar, simple bar. Okay. To enclose it. And these are processed by diagonal expansion. Diagonal expansion means we need to expand it. So what is diagonal expansion? That we taught in, or that we learn in the coming session. Okay, so that is diagonal expansion that we learn in the immediate section. Okay, today. So that is determinant. So what value we derive, that is a determinant. Okay, clear? So determinant, we can find determinant of each and every value, or that we call the element, okay, or the matrix, subject to it must be a square matrix. Okay, please note down. Okay, students, so we can determine the determinant of square matrix with any order. Clear? Subject to it must be a square matrix. It may be a order of 2, 2 into 2, 3 into 3, 4 into 4. Okay, but basically we have problems relating to 2, 2 and 3, 3 matrix. Okay. Clear, students? So now, is it clear what is determinant? Now, next we are going to discuss about the characteristics or nature of determinant. Characteristics or nature of determinant. Characteristics, or as we know, nature, feature, behavior of determinant. Okay. See, students, there are certain characteristics in the determinant that we have already discussed in the meaning. Okay, characteristics are derived only from the meaning. From the meaning, we can easily derive its characteristics. So, what is the characteristic? As we know, determinant is a numerical value. It is a numerical value. Numerical value means it's a number. It is a number. Okay. It is a number. When we find the determinant, what it? It was a number. Okay. So this means that it is expressed in terms of certain numerical figure. Okay. Only numerical figure. Clear? Those are derived. Okay. In numerical figures. Clear? It may be of any number. Okay. Any number. We can say numerical figure means any number. Okay. It may be a whole number or integer. We can say it is an integer. Okay. Positive, negative, zero. All can be a determinant. Okay. Clear, students? You might remember while we going through the types of matrix, there was a matrix that is called singular matrix. Okay. Singular matrix. So what is singular matrix? Singular matrix is the matrix in which the determinant is zero. That is called a singular matrix. Remember? So hence prove that the determinant can also be zero. Whenever it is zero, it is called singular matrix. When the determinant is not zero, that is called a non-singular matrix. Okay, students? So at that time, I have already indicated you that I will describe what is singular matrix when I will describe about the determinant. So today we are going to discuss about determinant. So I clear that particular type of matrix, that is what is singular matrix. Okay. So how to find the determinant, that we go through the today class. Okay. So second, that is the first. Second, Determinant, it is enclosed by bars. Okay, that is the indication. How we know that it is asked to find the determinant? Okay, what if I write 5, 6, 7, 8? 5, 6, 7, 8. What it mean? It has nothing. Okay, if I draw a square bracket, it means it is a matrix. What kind of matrix? 2 into 2, that is a square matrix. Okay, if I subject to ask to find determinant, what to do? It is an indication. Okay, how it indicated? It indicated like to find the determinant means in symbolically we can say bar. It means we need to find the determinant of this matrix. Okay, so it is enclosed by brackets. Okay, brackets are there. It means that is asked to find the determinant. Okay, clear students? Next, it is obtained from square matrix only. We can say only square matrix only. We can find determinant only from square matrix. If it is not a square matrix or other than square matrix, then determinant could not be calculated, derived. Okay, clear? Then next point is it is obtained from the coefficient of certain unknown variable. Where we obtained it? It is obtained from coefficient of unknown variables. Okay, as students, I have already discussed about who are the unknown variables. That is A11, A12, A13, A21, A22, A23, A31, A32, A33. These are the unknown variables. So there are some coefficient. Definitely those are represented, or that we call the element. Maybe I write the what in instead of A11. Clear? Or at that the place of A11, if I write 5, 6, 7, 8, 9, 0, 1, 0, 1. Okay, so these are the unknown variables. So what are the coefficient of those unknown variables? So 5 of A11, 6 is the coefficient, 7 is the coefficient, 8 is the coefficient, 9, 0, 1, 0, 1. All these are the coefficient. So we can obtain the determinant from coefficient of unknown variable. Those are the unknown variable. We can find the determinant using those coefficient. Okay, we can find by taking any of the coefficient, and we can find the determinant of all coefficients. Okay. Clear students? Then it has a large number of algebraic property. It has a large number of algebraic property. It has a large number of algebraic properties. Okay. Now determinant has a number of property. Around 8 to 10 properties are there. Okay, that we discuss in the later on classes. Okay. So in determinant we have large number of properties. Okay, clear students? So that is about the characteristics of determinant. Okay, so next we move on to the other part, that is minor and cofactor. Minor and cofactor. Clear? So please complete it. Then we can move on to the other portion. Friends, see. Okay. So next we have to discuss about minor and cofactor. What is minor? What is cofactor? That is also another part of determinant and which is important for matrix. Okay. So students, see, before moving towards minor and determinant, here I want to elaborate or evaluate that how to find the determinant. Okay, how to find determinant. We can find determinant, then only we can go for minor and cofactor. Okay. So, students, see, basically there are three methods of finding determinant. Okay, there are three alternative methods of finding determinant. Okay, those are the method of minor, the method of cofactor, and Sarah's diagram. Okay, and that we already stated in the example, that is the process is called diagonal expansion. Okay, that is diagonal expansion. Diagonal expansion, that is the most used method for finding determinant. Okay, so first of all, I want you all able to find the determinant. Okay, so that's why first of all it is preferably suggested by all and also by me just to prefer that diagonal expansion method. Okay, in the diagonal expansion method we have other minor and cofactor and Sarah's diagram. Sarah's diagram is also important. Okay, so first of all we need to go through the diagonal expansion method. Okay, so in the diagonal expansion method, how to solve, how to find the determinant in the diagonal expansion method. Okay, so there may be a question asked to find the determinant of a given matrix. A matrix was given and you are asked to find the determinant. Okay, clear? So it is very simple. So as I said, we can find determinant only if it is a square matrix of any order. Square matrix of any order. So here any order, that is second or third or fourth, clear, so on. Okay, we can find the determinant of square matrix of any order, maybe 2, 3 or 4. Okay, so basically regularly we are practicing second order and third order matrix only. Fourth and so on orders are not. That is most frequently used. Okay, for us now it is important to find the determinant of second order and third order matrix. Okay, so see, let's we discuss a problem, that is to find the determinant of a given matrix. First of all, I used to take a second order determinant. Okay, so see, if it was given 5, 4, 1, 3, or make it 2. Okay students, so see, it is a, what is it? It is a second order matrix. Okay, so if it is asked like this, it means, as I say, brackets are there, means it is asked to find the determinant. Okay, so see, so here we need to find the determinant. Let it is the name of this is A. Clear? Let the name of the matrix is A. Okay, the name of the matrix is A. So here we are asked to find A is the, what is A? A is a matrix, and we need to find A in the bracket. It means determinant of A. Determinant of A. What is A? A is the matrix. Determinant of that matrix. Clear? So it might, in the A matrix we have 5, 4, 2, 3. Now we are going to find the determinant of A. That is it is symbolized as A in the bracket. Okay, and we use a symbol for determinant, that is delta. Determinant A, or we say delta. Okay, is equals to, it's very simple. If it is a case of 2 into 2, if it is a case of 2 into 2 determinant, then it is very simple to find the determinant. Okay, simply what we do, see student, carefully please. In 5, 4, 2, 3, what are the unknown variables? The unknown variable of 5 is A 11 and 4, A 12. Okay, that is row 1, column 1, A 11, row 1, column 2, A 12. Similarly, row 2, column 1, row 2, column 1, row 2, column 2. Okay, so to find the determinant of second order, what we do, very simply, we need to do A11 multiplied by A22. Clear? A11 multiplied by A22 minus A21 multiplied by A12. Okay, clear students? A11 multiplied by A22, then A21 multiplied by A12. Okay, so that we calculate here. So in the place of A11, what is the value of, what is the coefficient of A11? That is 5 multiplied by the coefficient of A22 is 3. Clear? Minus, what is the coefficient of A21? That is 2 multiplied by coefficient of A12, that is 4. So now we have 5, 3, 15 minus 2, 4, 8. That is 7. That is the value of the determinant. Okay, clear students? Is it clear that how to find the determinant of second order matrix? Very simple. We need to multiply the diagonal, first leading diagonal minus other diagonal, two diagonal value. Okay, one diagonal, that is the, that we call, clear, that we call what? The leading, the principal diagonal. Clear? Multiply of principal diagonal minus the other diagonal. Leading diagonal minus other diagonal. Clear? Then we interpret the coefficient, the values, then we arrive the solution, that is determinant of A. Okay, each 7. Okay, clear students? Please. I hope all might able to know how to find the determinant of second order. Okay, see, one more example I will take. Example C. Let I take minus 1, 4, 3, 2. Okay, that is also asked to find the determinant of this. Now it's very simple. So here determinant is equals to A11 minus 1 into A22 2 minus A21 into A12 3 into 4. Now that is minus 2 minus 12. So here becomes minus 14. Okay, as I said, any numerical value, it might be positive, negative, any integer. Okay, it might also be 0. 0 can also be the value of the determinant. Okay, clear students? So that is about to find the determinant of second order matrix. Okay. So now I am going to third order. Okay, third order now. See, we have a matrix given as, let B is equals to, that is given 3, 2, 5, 4, 5, 6, 7, 8, 9. That is a matrix is given. Okay, a matrix is given and it is asked to find, that is the matrix, we are asked to find B. That means B between bars, it means we need to find the determinant of B. Okay, so now see, so here asked to find the determinant of a third order matrix, we simply write the value 3, 2, 5, 4, 5, 6, 7, 8, 9. Okay, we put the determinant symbol, determinant 1, that is enclosed by bars. Okay, then now we need to find the determinant of that matrix. So see students, so here we have 3 rows, row 1, that is row 2, and this is row 3. Okay, carefully, please listen it carefully, it is very important step. Okay, so we have 3 rows, row 1, row 2, row 3, that we say the diagonal expansion in the second order, we diagonally expand. Okay, diagonally, leading diagonal minus the multiplication of leading diagonal minus the other diagonal, that we say in the second order. In the third order we also use that method, but we have 3 values. Okay, so that's why we have to go through another process. What is that? See, so here we have 3 rows, row 1, row 2 and row 3. Okay, so first of all what we have to remind a basic rule. Okay, so that we can determine, find, okay, that we can determine or calculate the determinant by expanding okay, expanding row 1 or row 2 or row 3. We have 3 rows, we can expand any of the rows, okay, we can determine the value by expanding any of the given rows. Okay, so now, so it is clear that we can take either row 1 or row 2 or row 3, any row can be taken to find the value. So it is now important that while we are going to take row 1 or row 2 or row 3, there is a rule. Clear? That is a sine rule. That is called sine rule. Sine means plus or minus. Okay. We need to provide a sign to the corresponding coefficients, elements. That is, if we take row 1, that is a coefficient or element 3, 2, 5. Clear? So we need to provide a sign to those elements, and then we are applying the second order formula. Okay, so see, so what is the rule? The rule is, the sign rule is, if we take row 1, we provide the sign like plus, minus, plus. Okay, plus 2, the first element, minus sign is given to the second element, and plus sign is given to the third element if we are taking row 1. Okay, then if we are taking row 2, minus, plus, minus. If we are taking row 2, then we provide negative sign to 4, plus sign to 5, minus sign to 6. Clear? Then if we are taking row 3, then as usual, plus, minus, plus. Okay, that is plus sign for 7, minus sign for 8, and plus sign for 9. Okay, is it clear? That we can take row 1, row 2, row 3, any of the row, just we have to follow a simple sign rule, that if we take row 1, then we used to provide plus, minus, plus. If it is row 2, minus, plus, minus. If it is from row 3, plus, minus, plus. Okay, very simple to understand and easy to remind it, nothing to discuss over here. Okay, so now let us solve by taking all of the 3 rows. Okay, so first we should take, let me take considering row 1. Clear? Here we are considering row 1. So now we are considering row 1. So what is the way? See. So in the row 1, we have to take 3 first of all. So we used to see 3. Plus sign, that is plus sign, so plus. Now what we do? So while we take 3, the next process, that is the first process, take the first element, then second, next what to do? Delete or eliminate the entire row and column considering that value. So this is the value. Okay, we need to ignore or delete from our mind, not from here. Okay, we need to delete. We might think that nothing is there. What is not there? The row and column containing that element. So 3. What is the row containing 3? This is the row containing 3. And what is the column containing 3? This. Clear? We ignore both 3. The column and the row. So now we consider 3. Okay. Now 3 each multiplied by, now it is multiplied by the second order. Now here we need to find the determinant of the remaining item. So here we have a 2 determinant. Now here see 5, 6, 8, 9. Clear? First we consider, because of we are taking row 1, so first we take 3, then 2, then 5. Okay, so first we take, when we take 3, we have to delete the 4, 7 from the column and 2, 5 from the row. We delete from the mind, that is not here. Now we consider what remain. 3 we consider here. Now what remain? 5, 6, 8, 9. Clear? Now 4 was there. Here 2, 5. Now is the time for 2, because we are these factors are not here. We are only considering row 1. So 3 is over. Now is the time for 2. What is the sign given to 2? That is minus. So minus 2. minus 2. Now again we need to delete the rows and column containing that element. Clear? So what is the? That is the row and that is the column. Okay? We delete those. Now what remain? We have remain 4, 6, 7, 9. 4, 6, 7, 9. Okay? Clear? Now what remain? Okay students, now the third value. Clear? A11 over A12, now A13. What is that? 5. So what is the symbol? Plus 5. So here 5 plus 5. Now second, we need to delete. Clear? The row and column containing that element. So here 3 to 5 gun and 5, 6, 9 gun. That is the row containing 5 and that is the element containing 5. Okay. Now what left? 4, 5, 7, 8. 4, 5, 7, 8. So 4, 5, 7, 8. Okay. Clear? Now here the as usual we need to do simple 3 multiplied by, we need to solve this second order determinant. Okay. So here see 9 into 5. Okay students, 5 into 9, first of all we need to main bracket 5 into 9 minus 8 into 6. Okay, it might not be visible. Okay, see, first of all 3, now 5 into 9 minus 8 into 6. Okay, then minus 2 over, then minus 2 into 4, 9 minus 7 into 6. Okay, then 5 into 4 into 8 minus 7 into 5. Okay, clear students? Now simply we do a simple algebraic operation, that is multiplication, addition and subtraction. Okay, so now 3 multiplied by 9, 5, 45. 48 minus 2 into 9, 4, 36 minus 7, 6, 42. Okay, then plus 5 into 8, 4, 32 minus 7, 5, 35. Okay, then we expanded 3 into what remain? So here 45 minus 48, that is minus 3. Okay, then minus 2 into 36 minus 42, minus 6. Then 5 into 32 minus 35, minus 3. So what left? 3 into 3, minus 9. 3 3 is 9, minus 9. Here minus minus plus, 6 2 is 12. Here plus minus minus 15. So here we have negative figure 2, minus 15 and minus 9, that is minus 24 plus 12, that is minus 12. Okay, see, have a look over the calculation. I might be wrong. Hope it clear, students? Done? How to find the determinant of order 2 and the determinant of order 3. See, in the second order, it was very simple. That was the method that we use here. And in the third order, we just need to delete the row and column, and we need to assign a symbol, assign a sign. That is the two new factor. First of all, we assign sign, then we delete the row and column considering that element. Simple. Then the as usual second order process. Okay? Clear, students? I hope. So see, here we consider row 1. I'm also, for your kind clearance, I'm also considering row 2 and row 3. Okay, in all the cases, whether we take row 1 or row 2 or row 3, the same value that arise, that is minus 12. In all the cases, the answer derived is minus 12. Any factor you might take, that you arrive that same answer. Okay? Clear? So see, now it is over row 1. Now for your clearance, I am taking row 2. Okay? So here we might take row 2. Okay? Now we are taking row 2. So the symbol is minus plus minus. Very simple. What we do? See, students, I am deleting the row and column like that. You are not repeating the same because of I am using here the board. That's why I am easily clear it. But while doing in the notebook, you must not go through that process. Okay? Just delete it in your mind. Okay? That's why I am so here. In the next process, I might not gone through the deleting those factors. Okay? That we need to delete from mind. We need not to consider those row and column. Okay? So now we are taking row 2. Okay? So as usual, first we take, so what is the symbol? Minus plus minus. So for 4 we take minus, for 5 plus, for 6 minus. So minus 4 into, now what left? We need to delete the row and column considering, so here 2 gun, the column, the row. Now what left? 2, 5, 8, 9. 2, 5, 8, 9. Okay? Clear, students? Now 5. That is the symbol of 5 is plus. So plus 5 into, now delete the row and column considering that element. So that is the row and that is the column considering 5. 5 consists in this row, in this column. So we delete those row and column. Now what left? 3, 5, 7, 9. 9. Okay? Clear, students? Now 6, that is minus symbol for 6. So minus 6 into, now delete the row and column considering 6. Now what left? 4, 5, 7, 8. 4, 5, 7, 8. Okay? Now as usual, the same calculation. Minus 4 into 2 into 9 minus 8 into 5. Plus 5 into 3 into 9 minus 7 into 5. Minus 6 into 4 into 8 minus 7 into 5. Okay? Now minus 4 into 9 to 18. 18 minus 8, 5, 40. then plus 5 into 9327 minus 7535, then minus 6 into 8 4 32 minus 7535. Okay. Dear students, okay, now simply minus 4 into, see here, 18 minus 40, 18 minus 40, what left? 22, minus 22, plus 5 into 27 minus 35, what left? 8, minus 8, minus 6 into, what left? 32 minus 35 equal to minus 3. Then the next process, minus 4 into minus 22. So 22 4s are 22 4 students, 44, 88. So we have minus minus plus. Okay, 88 here plus minus, minus 85, 40 minus minus plus, plus 63, 18. Okay, then what left? $88 minus 40, 48. 48, okay. Okay, wait students. Okay students, just might be some error was there. Please wait a second. Sorry students, some calculation error was there. Okay, so now we are considering row 2, that is minus 4, now we need to delete, minus 4 we consider, now we need to delete the row and column considering. So now left 2589, 2589, clear? Then next 5. So the symbol is plus 5. Okay. So what? So the value considering these two. Okay. These two row and column. Okay. So 5 consisting this column and this row. So what left? 3, 5, 7, 9. Okay. Now for 6 we have minus 6. Okay. So what left? Minus 6. So we are deleting that. Now left 3, 2, 7, 8. 3, 2, 7, 8. Okay. Now simply we are going through the simple second order determinants calculation. Now minus 4 into 2 into 9 minus 8 into 5. Okay. Plus 5 into 3 into 9. 3 into 9 minus 7 into 5 minus 6 into 3 into 8 minus 7 into 2. Clear students? Now minus 4 into 9 to 18 minus 8 5 40 plus 5 into 9 3 27 minus 7 5 35. Now minus 6 into 8 3 24 minus 7 2 14. Okay. The next step, minus 4 into what left? 18 minus 40 is equals to minus 22 plus 5 into 27 minus 35 is equals to minus 8. Now minus 6 into 24 minus 14 is equals to 10. Okay. Now we are at the end position, that is minus 4 into minus 88. Sorry, minus 22. That is plus 88. Now see, here plus 5, here minus 8. So plus minus, minus 8 5 40. Now minus 10 6 60. Then what left? Plus 88 minus 100. That comes minus 12. Okay. Clear students? Now if we consider the row 3, clear? I request you all pause here, pause the video and gone through the calculation, clear? Then play and continue the session. Okay. Now if we are considering row 3, okay, now we are going to consider row 3. Okay, so now see, if we consider row 3, the formula, the sign plus minus plus. Okay, so plus 7 minus 8 and plus 9. Okay, so first consider 7. Now delete this row and column. What left? 2 5 5 6. 2 5 5 6. Okay, now minus 8. Minus 8 into, now consider or delete the row and column considering 8. What is that? This and this. So what left? 3 5 4 6. 3 5 4 6. Now plus 9. Plus 9. If you used to take plus 9, now delete this row and this column. What left? 3 2 4 5. 3 2 4 5. Okay. Now the simple calculation, 7 into 2 into 6 minus 5 into 5 minus 8 into 3 into 6 minus 4 into 5 plus 9 into 3 into 5 minus 4 into 2. Then 7, 6 2 is 12 minus 5 5 25 minus 8 into minus 8 into 6 3 18 minus 4 5 20 plus 9 into 5 3 15 minus 4 2 8. Okay. Then 7 into 12 minus 25, that is minus 13 minus 8 into minus 8 into 18 minus 20 is equals to minus 2 plus 9 into 15 minus 8, that is plus 7. Okay. Now the last step, that 7 into minus 13. 13 7 ja minus 91. Here minus 8 minus 2 minus minus plus plus 16 plus 7 63. Now what left? So we have minus 91 and in plus we have 16 and 63. So 16 and 63, that comes 79. Minus 91 plus 79, that comes minus 12. Okay students, as we see, if we take row 1, row 2 or row 3, that is not a matter. Clear? We can consider any of the row. So initially first we take row 1 always. Okay, always we take row 1, expanding row 1, because that is the first value and no confusion arise. Okay, out of that. So that's why I also suggest you to consider row 1, and it is not a matter if you consider row 1, row 2, row 3. Okay, whatever we can consider, in all the situation we arrive a common answer. Okay, clear students? So here we complete how to find the determinant of second order and third order matrix. Okay, now students, the next thing, we move on to minor and cofactor of a determinant. How to find the minor, what is minor and what is cofactor, and how to find those minor and cofactor. Okay, so see students, minor and cofactor of a determinant. Minor and cofactor of a determinant. Okay, see, so students, see, first of all, what is minor, what is cofactor, we gone through step by step. Okay, and how to calculate minor and cofactor, because the calculation of minor and cofactor is very important. Okay, for calculating or going through the detailed process in the matrix. Okay, so that's why we used to gone through the calculation of a minor and cofactor. Okay, so first of all we need to see what is minor and what is cofactor. Okay, so please write down what is minor. Okay, see, minor of an element, because an element means out of we have all the element A11, A12, A13, A21, 22, 23, A31, 32, 33. We can find minor of each and every element. Okay, clear? So what is minor? Minor of an element of a determinant is the subsquare determinant, of the given determinant. Subsquare of the given determinant along which the particular element, along which the particular element does not exist. The particular element, that is Aij, does not exist. Okay students, so what is the minor? Minor of an element of a determinant. We can find the minor of an element of a determinant. In a determinant we need to find the minor. Okay, so element of determinant is the subsquare determinant. That we used to say, that is the diagonal way. Okay, subsquare determinant of the given determinant along which the particular element does not exist. Okay, see student, it's very simple. What we did in finding the second order determinant, that is the process of finding the minor. Okay, that is the minor. And in the third order, okay, and also in the third order determinant, while we calculating the third order determinant, we also consider that process. Okay, there we can find the minor using that process. Okay, that is given over here, that what is minor? Now minor is the subsquare. Okay, subsquare determinant of the same determinant, considering the values, clear, considering the values in which the same or the factor that we find the minor does not exist. That means deleting the row and column consisting that factor, and the out of the remaining factor we find the minor. Okay, clear? So for that purpose, see, if we consider here an example of two order, A11, A12, A21, A22, okay, that is the second order. So what we do, the minor that we used to say, so here we can find the minor of all the elements of it is A11, A12, A21, A22. Okay, and one more point here, you to write that what is that? Now minor is minor is indicated in a symbol as Mij. Ij means minor of the value. Ij is the place. Clear? We need to find the minor of an element. So how we recognize the element? By its place. What is the row, number of row, and what is the number of column. Okay, so that is the minor of that factor. Okay, clear? So here if we say the minor, we can find the minor of all the element, whether it is A11 or A12 or A21 or A22. We can find the minor of all the elements. So the minor of A11, so here we indicate, that is, we need to indicate it in its own language. So what is the language? The language is Mij. So here Mi, row 1, column 1, M11. So here for A12, what it? Simple, M12, A21, M21, A22, M22. Okay, clear? Okay students, now see, while we going through the second order, what we do? It's very simple. The minor of A11 is okay. You please note it here that minor is indicated as Mij. Okay, Mij means I for the number of the position of the row and the position of the column. Clear? So while we are going to calculate the minor of a second order, that is minor of A11, that is M11, okay, is indicated as match, see, the opposite value of the diagonal, clear. See, the minor of A11, see, we have not a process if it is a case of third order, that we calculate by using the what we did in the last process while determining the determinant, okay, finding the determinant of 3 into 3 order. But in 2 into 2 order, very simple, the opposite value of the same diagonal, A11, clear, the diagonal is clear, A22, so that is the opposite value. So the minor of A11 or M11 is equals to the value of A22. Simple. Now the minor of A12 is A21. A21 is A12. Okay. Now the minor of A22 is A11. Okay. The minor of A11 is A22, that is the opposite. Minor of A12 is A21. A21, A12, A22, A11. Okay, that is the minor in second order. Okay, now what if it is a case of third order determinant? Okay, in case it is a third order determinant, it is also very simple that we did in the last process. Okay, see what we do. If it is A11, A12, A13, A21, A22, A23, A31, A32, A33, those are the elements. Okay, so we can calculate the minor of all the elements over here. Okay, so here the minor of A11, that is M11, minor of A12, that is M12, minor of A13, that is M13. Clear, students? Now same we can continue, that A21, that is M21, A22, that is M22, then A23, that is M23. So what is the minor? See, so very simple, the minor of A11, what we did, deleting the row and column considering the value. So A11, so deleting this and this. Now what left? The left is A22, A23, A32, A33. Simple. Okay, now what we do? A22 into A33 minus A32 into A23. Plus, that is the minor. That is the minor of a value. First of all, deleting the row and column considering that element. Now what left? We need to find the determinant of that 4 elements. Clear? First of all, we delete over here. We delete the row and column containing A11, this and this. Now what left? A22, A23, A32, A33. Now A22 into A33, A32 into A23. That is the value. Clear? Same if we take, same. If we are going for A21, what is A21? Deleting the row and column. This and this. Now what left? A12, A13, A32, A33. A12, A13, A32, A33. Now multiply it. A12 into A33 minus A32 into A13. Okay? Clear, students? Is it understand? Clear? How to find the minor of each and every element? Okay? So don't worry, it is symbolically. Now here we consider a value. Okay. So for you, I am here considering a value. Same example. Okay, see. Instead of these places, I use some figures. Let first we take, let 5, 6, 7, 8. If it is 5, 6, 7, 8. Clear? And here we are asked to find the minor of A11. Okay, the minor of A11. That is, Karo. The minor of A11. That means A11, that is 5. That is M11 is equals to 8. Opposite, simple. The opposite. Now, the value of A12. What is the value? A12, 6. That is M12 is equals to, simple, the opposite. The opposite of 6 is 7. Okay. Now, A21, 7. That is M21. So the opposite of 7 is 6. Now, A22, that is 8. The opposite of 8. 8 opposite is 5. Clear? See, have a look. Have a simple look, students. Okay, students, clear? So now, this was the example of second order. Now, we take the example of third order. Okay? See, the value we use over here. Okay. Let me take -1, 2, 3, 6, 4, -2, 1, 3, 4. Okay, this might be the example. Okay, now we need to find the minor of any element. We can take any element. Okay, so first let we take the minor of 4. Okay, minor of 4. So what is the value? A21, A22, the minor of 4. That is A. What is the value? A21, 22, A22. That is M22 is equals to, very simple. Now what we do? Delete the row and column containing 4. That is this and this. Now what left? The left is -1, 3, 1, 4. Now simply find 4 into 1, -1 is equal to -4 minus 3 ones are 3. That comes -7. Okay, so the minor of 4 is -7. Clear, students? Now let we take the minor of this. See, let the minor of this. Okay, this one. So what is the position? The minor of 1. That is A31. So we indicate as M31. Minor of the, what is the position of the element? 31 is equals to, so delete the row and column. This and this gone. Now left 2, 3, 4 minus 2. 2, 3, 4 minus 2. Then what left? Then 2 to the 4 minus 4 minus 4 3 is a 12. That comes minus 16. Okay, students, I hope all are clear. Now if we take, like see 3, the minor of 3, that is the value A13. So that is M13 is equals to, now delete the row and column, this and this. Now what left? 6413. 6413. Okay. Now 6318 minus 4 ones are 4. That comes 14. So the minor of 3 is 14. Okay. Clear? I hope it is clear, students. Please have a clear look. Then we go for cofactor. Okay, students. Now, see the last thing that we gone for today, that is the cofactor. Okay, after completing the cofactor, we end the class here, and then next we go to the other sections. Okay, so now we are going for calculating the cofactor. Okay, students, see what is cofactor? What is cofactor? As like minor, we can also find the cofactor of each and every element of the given determinant. Okay, in a determinant we have number of elements, so we can find the cofactor of all the elements. Okay, so what it means? See, cofactor. The cofactor of an element in the determinant is the product of minus 1 to the power I plus j, minus 1 to the power I plus j, the product of minus 1 to the power I plus j and the minor of that element, that is mi plus j. Okay, so symbolically we can say, cofactor is denoted by Cij. Okay, Cij for the cofactor of what? Positional element. What is the number of row? What is the number of column? So Cij is very simple, equals to, remind the formula, minus 1 to the power I plus j into m to the power I plus j. M to the power I plus j. Clear? That means it's very simple. As recently in the some time before, we used to calculate the minor of an element. Clear? Simply calculate the minor of that element. So put over here and then multiple that value with minus 1 to the power I plus j. So what is I plus j? I, for example, if we are going to find the cofactor of 3, 1, that means the cofactor of the element of row 3 column 1. That is simple minus 1 into what we put over here. I. Here I means 3 and j means 1. Row 3 column 1. Okay. Into m I plus j same 3 1. Okay, clear students? That we find the cofactor of the element, so we consider the value of that element. So here I means 3, j means 1. I means 3, j plus 1. And just simply we need to find the minor of that element, or the minor of A31. Then we multiply that value with minus 1 into minus 1 to the power I plus j. Okay, clear? Now here we use a problem. Okay, so first please look over here, consider it, memorize it. Okay, do whatever how you could do it. Okay students, so see, here again we are considering two examples, that is of order 2 and order 3. Okay, I am directly taking the valuable matrix determinant. Okay, see, if it is a case of order 2, like 2 3 4 1, if it is 2 3 4 1, clear? So here we are asked to find the cofactor of 2. The cofactor of 2. Okay. 2 means what is the position? A 1 1. The position is important over here, students. Mind it. The position is important. So the cofactor of 2, that is A 1 1, row 1 column 1. That is here what we symbolize? We symbolize C 1 1. C 1 1. Okay. Okay, students. So see. So C11 is equals to, very simple, put up the formula, minus 1 into 1 plus 1. 1 plus 1 into minor of 1 plus 1. Okay, so what we do? So here minus 1 into 1 plus 1 is equal to 2 into M11. What is the minor of this element? The minor of A11 is equals to 1. The minor of A11 is equal to A22. That is, the value is opposite. Simple. 2 opposite 1. The minor of 2 is 1. The minor of 3 is 4. Minor of 4 is 3. Minor of 1 is 2. Okay. So minor of 2 is 1. So here, what here? So minus 1 2 times. That is plus 1. So plus 1 into plus 1 is equal to 1. So the cofactor of 2 is equal to 1. Okay. Clear? Now, the cofactor of, let 3. What is the position? A12. That is C12 is equals to minus 1 to the power 1 plus 2. Clear? I plus j, 1 plus 2 into minor of 1 2. Minor of the 12th. Now, minus 1 into 1 plus 2 3 into, what is the minor of 3? Minor of 3 is 4 into 4. So what left? Minus 1 3 times. That means minus 1. So minus 1 into 4 is equals to minus 4. Okay? Clear? Now, the the cofactor of let this value 4, okay, 4, that is A21, that is C21 is equal to minus 1, 2 plus 1 into minor of 2 1, that is equals to minus 1 into 2 plus 1 is equals to 3 into minor of 4 is 3. So what left? Minus 1 3 times means minus 1 into 3 is equals to minus 3. Now the cofactor of 1 that is A22, that is C22 is equals to minus 1 to the power 2 plus 2 into minor 2 2 is equals to minus 1 to the power 2 to 4 into minor of 1 is simply 2. So here minus 1 4 times means plus 1 into 2 is equal to plus 2. Okay, clear students? So here we calculate the cofactor of second order determinant. Okay, now is the time for third order. Clear? So here we consider a third order let it 0, 2, 3, 5, 6. Okay, clear students? So this is a third order determinant. Okay, now the cofactor, we need to find the cofactor of, what is the value? What we find? See, we find the value of 0. Okay, the cofactor of 0. What is the value or what is the position? A 11, 12, 13. A 13, that is C13 is equals to minus 1 to the power 1 plus 3 into minor of 1 3. Okay, now here we need to find minus 1 into 3 plus 1 is equals to 4 into minor of 1 3. Minor of 1 3. So here what is the minor? So delete this. What left? 4 1 3 5. 4 1 3 5. Clear? Now minus 1 into 4. So minus 1 into 4 means plus 1. Plus 1 into here 4 5 20 minus 3 1 3. That is 1 into 17. 20 minus 3 is equals to 17. Okay, so the value comes 17. Okay, so the cofactor of 0 is 17. Okay, plus 17. Clear students? Now, suppose we take the cofactor of any one value, let 5 over here. 5 over here. So what is the cofactor of 5? So what is the position? A31, A32, clear? A32. Now that is A32 means C32 is equal to minus 1, 3 plus 2 into M32. Okay, so minus 1 to the power 3 plus 2, 3 plus 2 is 5 into M32, minor of M32, that is 5. So deleting this, what left? 2042. 2042. So minus 1 5 times means it is minus 1 into, that is 2 2 ja 4, sorry 2 2 ja 4 minus 400, that comes minus 1 into plus 4 is equal to minus 4. That is the cofactor. Okay, so as an example here I take 2 elements. You can find the cofactor of all the 9 elements. Okay students, so please do carefully gone through your books or any question that you have regarding to find the determinant of second order, third order. Okay, to find the minor of second order and third order determinant, to find the cofactor of second order, third order and determinant. Please have a practice over those questions. If any doubt arise, then please answer question me. Okay, put your question in the comment section so that I could in the later on classes or in the comment section can clear your doubts. Okay students, clear? So for today we end up our class over here. In the next class we gone through the other concepts of matrix and determinants. Okay students, thank you.